All right, let's look at these two definite integrals. We're going to calculate these two definite integrals using the fundamental theorem of calculus. One of them, our inside function, is a polynomial. The other, our inside function, is a trig function. Both of these are continuous on the intervals that I'm provided from -1 to 2 on this polynomial. This polynomial is continuous. The trig function is continuous between 0 and pi/2. In fact, these are both continuous on the real number line, so any interval we chose would have been fine. In this first integral, we take an antiderivative of our inside function. One antiderivative is going to be 2/3 x to the third minus 5/2 x squared minus 3x plus the constant of 0. We're going to be integrating between -1 and 2. Notice we're going from -1 up to the number 2. That means I'm going to plug in 2 as my first value. I would get 2/3 multiplied times 2 to the third power minus 5/2 multiplied times 2 to the second power minus 3 multiplied times 2. That's just what I get when I plug in 2. When I plug in -1, I have to do the exact same thing. In fact, let me copy and paste and replace. I'm going to replace every 2 with a -1. So that's what I get. We're going to type this into our calculator and get an answer. You can do this in either 2 steps or 1 step. I think I'll do this one in 2 steps just so we can see how it's done and what I mean by 2 steps. When I say 2 steps, I'm going to simplify what's in this left-hand bracket, simplify what's in the right-hand bracket, and then I'll plug them those numbers each into here, and then I'll subtract. When I plugged in the numbers, this left hand, or the expression, once you plug in a 2, should become -10 and 2/3. If I plug in a -1, that expression became a -1/6. Subtracting, now be careful here, we're subtracting a negative. So we take -10 and 2/3, and we're actually adding 1/6. By doing that, we get a final answer of -10.5. -10.5 is the signed area between this curve and the x-axis, signed area between -1 and 2. Obviously, because this is negative, that means my curve for most of this region probably went underneath the x-axis. Definitely went underneath the x-axis, but so there we go. How about cosine of x? integrated from 0 to pi over 2. Let's go ahead and do that one. The antiderivative of cosine x is positive sine x. We're going to be integrating that between 0 and pi over 2. That means I can plug in pi over 2 into the sine function and then subtract what I get when I plug in 0 into the sine function. If you plug in pi over 2, sine of pi over 2 is 1. So I got 1 minus sine of 0 is 0. And therefore, this definite integral just has 1 as the answer. In other words, this definite integral is equal to 1. The signed area underneath sine from 0 to pi over 2 is 1 unit. So there you go on these two problems. We see now how to take definite integrals, and this saves us quite a bit of time over the idea of approximating with Riemann sums. I hope you've noticed that approximating with Riemann sums, first, you just get an approximate answer for the signed area. And then second, that approximate answer took you a long time to get. This is a much, much smoother process and more straightforward process most of the time.